What is this? I can't even understand a thing. Someone, please help me. Anyone? Whoa, who are you?
I'm a fairy, little boy. Why are you wondering?
I just don't understand about the periodic table, especially P, D, and F.
Oh, it's okay, dear. I have a solution for you.
Where are we?
Anywhere on this earth. Okay, now little boy, I want to show you the simplified form of the P block of periodic table, specifically in their electronegativity.
P-block elements of the periodic table is home to the biggest variety of elements as it is the only block that contains all three types of elements, which are metals, nonmetals, and metalloids. The elements are located in P-block as their valence electron fill the P subshell. P-block elements are placed from 13th to 18th group of the periodic table. Group 17 of the P-block elements are also known as halogens. Halogens are non-metallic elements in group 17 of the periodic table. The halogens as a group are extremely reactive. Electronegativity of an element is defined as the ability of an element to attract an electron in order to attain a stable octet configuration. Going down group 17 in the P block, the electronegativity decreases as the atomic size increases with the addition of a main orbital. Forces of attraction between the proton in the nucleus and the valence electron decreases, therefore the tendency to accept electron also decreases. This can be described with an analogy where the taller male managed to attract the female's attention. In this case, the male is described as the element located at the higher level in the periodic table, for example, fluorine, while the female is the electron. The more electronegative an element is, it would be easier for it to attract an electron to form the stable octet configuration. This can be described when the male at the higher level in the periodic table, for example group 17 fluorine, attracts the attention of the female.
I think I understand the P block element, especially in terms of the electronegativity. The higher the position of the element in P block, the more the electronegativity it is. Wow, that technology is so awesome, by the way. What? Where did he go? I still need help on explaining the D block element.
Hi there.
Whoa, whoa, whoa. Where's the other fairy?
Well, you need your help in the D block, right?
That's right, yeah.
Well, that fairy is an expert on the P block, while I'm an expert in the D block, so I'm gonna help you.
Okay.
Okay, look at the bridge over there. I'm gonna use that bridge to explain the D block.
That bridge? Seriously?
Yes. Are you coming?
Yeah.
D-block elements are also known as transition elements. Nearly all transition elements have typical metallic properties such as high tensile strength, ductility, malleability, high thermal and electrical conductivity. In the construction of a building, the bridge acts as the building blocks that holds two or more buildings together as strong as it can. Just like the transition metals, the bridge is very strong and can withstand high heat to ensure the stability and life of the building. Transition metals are intermediate between the properties of S-block elements and P-block elements. Transition metals are like a bridge that interconnects both parts of the building to enable people to commute through. Similarly, transition metals connect the periodic table, the S-block and the P-block, which shows the transition from metallic to non-metallic nature of the elements.
Whoa! Another fairy? Wait. You must be the F block element fairy, right?
Yes, I am. I will explain to you regarding F-block elements. F-block contains lactanides and actinides. Lactanides, they are less reactive and less basic, whereas for actinides, they are reactive and unstable. Now, let me show you something. Come follow me. Come on, please.
Okay.
Hurry. Here we have reached our destination.
The classroom?
Yes, come on. Let us start from lanthanides. Lanthanides are described as the passive and reserved in group conference while discussing their coursework. From what we can see here, the girl with checkered shirt is quiet and passive among the other group members, and she signifies the lanthanides characteristic. The representatives of the groups are very kind to each other and readily shares information with other groups, which is rare to find these days.
Oh, I see. But how about actinide?
Actinides can be easily explained by using this example in a classroom environment with a number of students that exceeds a certain number. It would be difficult to control the classroom because high number of students would create a learning environment that is not stable. Not stable in terms of crowd control and effective learning absorption. And same goes for actinides. When atomic number exceeds 83, which is the maximum nuclear number, the element becomes unstable and radioactive.
Wow, that sounds great. Thank you.
Well,
Do you understand now?
Yes, I understand all of it. But can you please summarize all of it for me so that it's easier for me to write it down in my study note?
Sure, my dear. I can summarize the P block for you. You only have to remember, the higher the position of the elements in the group, the higher the electronegativity of the elements, just like how the tallest guy attracts the pretty girl.
F block, it consists of lactanides and actinides. Lactanides, they are less reactive and less basic, whereas for actinides, they are unstable and radioactive. It is radioactive because it consists of higher number atomic, which is 83. This can be shown in the classroom environment with a high number of students, and it is really hard to control the learning environment. This can signify the characteristic of actinides, and it is vice versa.
Okay, for D blocks, remember about the bridge that we walk on. It connects one place to another place. Just like the bridge, the D blocks connect the P blocks and the F block. And lastly, the D block is combination of metals and non-metals.
Thank you so much. Finally, I can understand the P, D, and F block element.
You're welcome.